first episode of Science Talks, a new weekly podcast that aims to bring you essential and fascinating insights into the world of science and medicine. In today's episode, we'll be discussing a topic that has been the focus of much media attention and fear for both the medical community and the general public: superbugs. First of all, what exactly are superbugs, and just how worried should we be?
The general definition of superbugs is strains of bacteria that have become resistant to antibiotics. In order to fully explain why this happens and how, we first need to understand what bacteria are and how antibiotics function under normal circumstances.
Bacteria are single-celled microorganisms, on average about 100 times smaller than the width of a human hair, but very widely in size and shape depending on their species. Many species of bacteria cause humans no harm, and some are even necessary for our health, but some can cause us to become ill. These are called pathogenic bacteria and can create disease in a number of different ways.
One of the ways in which bacteria cause disease is by multiplying and invading the body. They may also produce toxins, which are poisonous substances that interfere with our body's normal functions. When infected, we may also feel ill because of our own immune response, the body's defensive response to the bacteria, as well as the bacteria's own action.
Antibiotics are chemicals that can be used to treat bacterial infections. They work by targeting the bacteria and preventing them from growing. Different classes of antibiotics work in different ways.
Some antibiotics work by interfering with the bacteria's production of their cell wall, which is their outer coating which protects them from their external environment. Bacteria grow and split in two in order to multiply. When the cell wall is damaged, they burst before completing the process.
Other types of antibiotics prevent the bacteria from being able to make important chemicals they need to survive, or by interfering with their genetic information, which stops them from being able to grow and divide. Different antibiotics work on different bacteria. Some will only work on a few specific species, while others can target a wider range. Therefore, it's important to know what type of infection a patient has so they can receive the right treatment.
Now that we understand how bacteria and antibiotics normally work, we can begin to talk about how and why it sometimes goes wrong. That is, antibiotic resistance.
Antibiotic resistance basically means that the bacteria develop a way of stopping the antibiotic drug from damaging them, so it is no longer an effective treatment. Resistance can develop and spread in bacteria through a number of ways.
Firstly, bacteria may spontaneously develop a mutation, that is, a random change in its DNA. DNA acts as instructions for how the cell works. A mutation can therefore alter a cell from non-resistant to resistant. Secondly, a bacterium can receive genetic material from other bacteria or even from viruses. So if one bacterium in a population develops resistance, it can soon spread to other individuals.
So how exactly does a change in DNA cause bacteria to resist antibiotics? One way is by causing the bacteria to inactivate the antibiotic. Another way is by activating mechanisms in the bacterium that allow it to carry on functioning despite the effects of the antibiotics.
Obviously, this creates a serious problem for a patient and their doctor. On a wider scale, it means that there are no longer so many effective treatments, and more bacterial infections are becoming harder to treat. Some even develop resistance to more than one antibiotic, forcing doctors to use ones that are less effective and with worse side effects.
One of the most infamous superbugs these days is MRSA. It's been on the news and posters in hospital walls, and doctors' surgeries warn us about it. The effects we've described above means that people who are in hospitals already sick can be at risk of catching a hard-to-treat bacterial infection on top of their other medical issues. It's a good example of why superbugs are so dangerous, and why it's so important to understand and prevent them.
Widespread antibiotic resistance is the overuse of antibiotics to treat patients who don't need them. This is because of something called natural selection, and it works like this.
In a group of bacteria, anyone may develop a mutation that creates antibiotic resistance. If antibiotics are added, this means that bacterium now has an advantage over the others, and it's more likely to survive. When treatment stops, only the resistant bacteria survive, and the population that grows from there will all have the genes for resistance.
When antibiotics aren't used unnecessarily, having the genes for antibiotic resistance can make absolutely no difference. Those bacteria are just as likely to live or die, and the group keeps the majority of non-resistant bacteria.
For this reason, it's important for doctors to only prescribe antibiotics when they are really necessary, and and for patients to complete their medication as they are instructed. Never take antibiotics that have been prescribed for someone else and don't store them for later. It's also important not to try using them to treat colds or flu. They won't do you any good, as flu and common cold are actually viral infections, not bacterial.
Another way of preventing the spread of superbugs is to ensure you have good hygiene. Always wash your hands after using the toilet, before eating, or between visiting sick friends or relatives. We hope you found this video interesting and have become more informed on the topic of superbugs.
Join us next time for a new and fascinating episode of Science Talk.
Goodbye.